We are at the point in our discussion where we are ready to discuss the definition of the moment vector and its physical significance. I'd like to explain this concept by showing you an example. Let's say I have an object, and this object is a rod that I'd like to place along the x-axis. I'd like to make sure that this rod does not move, therefore I'd like to apply a pin at its left end. Let's call that point O. The right end, let's call that point A, and the length of this rod is, let's say, 5 inches. Let's apply a force in the negative z direction and apply that at point A. The magnitude of this force is, let's say, 125 pounds. Well, a force applied to a solid object has two effects. Number one, it tends to accelerate the object, which is not the case here because the rod is pinned at point O. Number two, it tends to cause the object to rotate. The 125-pound force tends to cause the 5-inch rod to rotate about point O. In fact, if we take this one step further, we can expect that tendency to rotate to be in that particular direction, about point O. There is a terminology that is associated with this concept. It is called moment. And by definition, moment of a force about a point is a measure of the tendency of the force to rotate a body about that particular point. The key phrase in that definition is tendency to rotate. Well, let's quantify this definition for this particular problem. There are two important elements in this definition. Number one is magnitude, and the second is direction. Well, what is the magnitude of the tendency of the force to rotate the 5-inch rod about point O? Since 5 inches is perpendicular to the force, isn't the magnitude just 5 inches times 125 pounds? What about the sense of direction? Isn't the direction just about the positive y-axis, which is in this particular direction? Let's express this mathematically. Moment about point O is a vector because it has magnitude and it has direction. By definition, moment about a point is equal to r cross with f. This is a vector operation called the cross product, which I'm sure you are very much familiar with. Moment about a point is always r cross with f. It's never the other way around, never f cross with r. The r vector, isn't that just 5 inches expressed in Cartesian vector form? Since we're trying to find moment about point O, the r vector needs to be from the point you're taking moment, which is point O, to the point of application of the force. From O to A, well, that's just 5 inches in the positive x. Expressing that in Cartesian vector form is 5i hat plus 0j hat plus 0k hat. And we need to cross this with vector f. Isn't vector f just 125 pounds expressed in ijk? The force is in the negative z direction, so therefore this is 0i hat plus 0j hat minus 125k hat. I'm sure you all know how to perform the cross product, but I'd like to perform this cross product just as a review. Both vectors, r and f, they must be expressed in Cartesian vector form. That is a must in the cross product. Since the r vector is the first vector in this operation, that must be placed in the first row. Order matters. This cannot be switched. So therefore the first row is 5, 0, 0. The second vector in this operation is of course vector f, and of course this must be placed in the second row, and again order matters. So therefore this is 0, 0, negative 125. If you remember how to perform the cross product, you pivot on I and you cross out everything below I, everything parallel to I. The 4 remaining numbers will be associated with the I hat and you cross multiply them. 0 times negative 125 is 0, minus 0 times 0 is 0. And you do the same thing for J. You pivot on J, cross out everything below J, everything parallel to J, and in addition to that, there must be a negative sign in front of the J hat. The 4 remaining numbers are 5 times negative 125 is negative 625, minus 0 times 0 is 0. Finally, you do the exact same thing for K, pivot on K and cross out everything below K, everything parallel to K, and you cross multiply the 4 remaining numbers, which are 5 times 0 is 0, minus 0 times 0 is 0. I'd like to remind you that there is a positive sign in front of the I hat, a negative sign in front of the J hat, and a positive sign in front of the K hat. So therefore this is 0 I hat minus a minus becomes a plus, plus 625 J hat plus 0 K hat. Moment about point O is a vector. The magnitude is 625. The sense of direction is about the positive y-axis, and the unit is inch-pounds. R is in inches, F is in pounds, so therefore moment about point O is in inch-pounds. 625 is the magnitude of the moment of the green force about point O. Well, that's just the magnitude of the rotational force. This J hat is the sense of direction of that moment about point O, which is the axis of rotation associated with the magnitude following the right-hand rule. So if you perform the R cross with F, and if you follow the right-hand rule, your right thumb will have to point in the positive Y direction, and your forefingers will want to curl in this particular direction. And indeed, this particular direction was the direction that we had expected for the tendency of the 125-pound force to rotate the 5-inch rod about point O. That's that same sense of direction. I'd like to point out 4 very important points in this discussion. Number 1 is that moment about a point is a vector, and by definition it is always R cross with F. This cannot be switched. It cannot be F cross with R, it's always R cross with F. Number 2, the R vector needs to always go from the point you're taking moment to any point on the line of action of the force. The 125-pound force has this line of action. Therefore, in essence, the R vector could go from this point to this point, or to this point, or to this point, or in fact any point along the line of action of the force. We had chosen point A because it was pretty clear how to get from O to A, which is just 5 inches in the X direction. So again, the R vector has to always go from the point you're taking moment, which in this case is point O, to any point on the line of action of the force, and we chose for this problem point A. Number 3, the moment vector is always perpendicular to the plane that is created by R and F vectors. If you look at the R vector that is in the positive X direction, the F vector that is in the negative Z direction, so therefore the plane that is created by these two vectors is the XZ plane. And if you look at the moment vector, your thumb points in the positive Y direction and your forefingers curl in a particular direction. It is always perpendicular. The moment vector is always perpendicular to the plane that is created by R and F. Number 4, the easiest way to find the measure of the tendency of the force to rotate a body about a particular point is to use the cross product. You must always remember that, again, it is always r cross with f, and all you have to do is find the Cartesian vector form of r and also of f. Perform the cross product and it'll immediately give you the magnitude of the moment about that point and its sense of direction. However, if you are good in visualizing forces and their effects, I'd like to show you some shortcuts, which will be in the next lecture.